Hola, 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 probando. ¿Cómo están muchachos? ¿Todo bien, todo azul? All right. Today we're going to continue with the Kepler's law. All right. And obviously solving a few problems on that one. Just hold on a second. Let me erase the whiteboard. And remember, if you have doubts or questions, don't hesitate to let me know. All right. I'm going to erase that one. All right. This is going to be the Kepler's law or Newton's gravitation law, if the same. All right. Let's going to begin with the first example, at least the first sample of the day. All right. All right. The problem says an artificial satellite and artificial satellite, artificial satellite, artificial satellite circling the Earth, circling the Earth, circling the Earth, completes each orbit complete each orbit in 110 minutes. In 110 minutes, period. The first question is letter A. Find the altitude, find the altitude of the satellite. Find the altitude of the satellite. And the letter B is, what is the value of G, or the gravity? What is the value of G? What is the value of G at the location of this satellite? At the location of this satellite. This is going to be the second question. What is the altitude of the satellite and what will be the value from the gravity at this location? All right. What we have to do in this case. All right. First of all, let's going to analyze what will be the behavior of the problem. I know this is not necessary, but if you want to do it, you can do it. That will be good, good one reference. For example, this is the planet Earth. Okay. This is the planet Earth. Get it over here. Da-da-da. All right. And you know, the distance from the center for any point, this is what we call the radius of the Earth. That will be this orange one's distance, the orange line. That will be the radius of the Earth. And according from the problem, there's gonna be some kind of additional distance. This is represented by this red line. And this additional distance is will be there located the satellite. This satellite that's supposed to be under the surface of the Earth, located over here. This is the satellite. And according from the problem says, oh, okay, the radius of the Earth, remember, is a constant value given by 6.38 times 10 at the 6 power meters. Is the distance between the orange line and the purple line. We don't know what will be this distance. We're talking about some kind of height h. So we don't know exactly what will be the value from h. This is what the problem is looking for. And after that, according to the location of the satellite, what will be the value of the gravitational acceleration in this position. Okay? So what we're going to do? Simple. The first thing that we must do is calculate what will be the period of time. Remember the period of time, t squared, that will be given by the formula 5 squared radius is the cube power divided by the constant gravity of the universal constant gravity over the mass of the planet. This is going to be the gravitational formula. And what we're going to do, we must be looking for what will be the radius in this situation will be the total distance between, we can say this point A until the point B, if you want to say in that situation. So in simple merely words, we can take the product between the period second power multiplying G and P, remember the mass of the planet, divided by 4 pi second power cubic root, and that will be the total radius that we're talking about. I mean the distance between the point A until the point B. So let's go to substitute. For example, we have 110 minutes, the period of time. But remember, we are not working in minutes, we're working in seconds. So remember 60 seconds, 1 minute, we have 60 seconds. So this period of time will be given by 6,600 seconds. So we got 6,600 seconds. Elevated the second power. The gravitational constant, remember, is 6.67 times 10 at the negative 11 power newtons meter square over kilograms second power. And the mass of the planet, Earth, remember, 5.98 times 10 at the 24 power kilograms. All right, and this expression divided by 4 pi square, taking the cubic root. And this is going to be the value from the radius. Remember this total radius that gave us the total distance between the point A until the point B. I mean the orange line plus the red line, as a matter of speaking. So what we're going to do, let's going to calculate the expression. 6,600 elevated the second power multiplying by 6.67 times 10 negative 11 power multiplying by 5.98 times 10, 24 power, divided by parentheses 4, 5 square, close parentheses, shift, cubic root of the answer. Well, actually the radio will be scientific notation 7.61. Sorry. The total radio will be 7.61 times 10 at the 6 power meters. This is going to be the total radio. I mean, the distance between the point A until the point B. But we are looking for what will be the value from H. It's simple because we're looking for what will be this Earth surface. The only thing that we have to do is, so in simple merely words, to find out H, we must subtract the total radio minus the radio of the Earth. In simple merely words, we have to subtract 7.61 times 10, 6 power meters minus 6.38 times 10 and the 6 power meters. And the height will be given to minus 7.61, sorry, 7.61 times 10, 6 power minus 6.38, 6 power. The answer will be 1.23 times 10 at the 6 power meters. And this is going to be the solution set, at least for the first question. The first question was, okay, what will be the value from the altitude of the satellite? When we're talking about 1.23 times 10 6 power meters, or if you wish, 1,230 kilometers about the Earth's surface. And obviously, this distance plus the areas of the Earth gave us 7.61 times 10 that's 6 power meters. That was the first question. Now the second question is, okay, what will be the gravity? I mean, remember, we have some kind of equation of the gravitational acceleration or centripetal gravitational acceleration or the gravity. Remember, what was this equation? Remember that equation, it's given by G times M over square radius, right? Remember, originally the centripetal of the force that will be equals Gm1 and 2 or R squared. And force, mass, and acceleration, we can cancel one of those masses, and the answer will be that situation, okay? So the problem asking for what will be this is, what will be the this gravity or the value from AC, and simple merely words. Well, the only thing that we must do is substitute. I mean, the value from G is 6.67 times 10 at the negative 11 power newtons meter square over kilograms second power, multiplying by the mass. What mass? Obviously the Earth mass. 5.98 times 10 at the 24 power kilograms, and divided by the square radius. What radius we were talking about? Because it's the location of the satellite, that will be 7.61 times 10 at the 6 power meter second power. So this centripetal acceleration, that will be the gravity of the satellite at that location. So 6.67 times 10 negative 11 multiplying by 5.98 times 10 24 power divided by 7.61 times 10 at the 6 power second power. The answer will be Vamos a ver, esta es normal. 6.89. 6.89 meters per second square. And this is going to be the solution set, at least for the first problem. Questions? Preguntas. ¿O está claro? ¿Mi estimados?
Mister, esa es la aceleración.
Sí. El AC, la aceleración gravitatoria, o lo puede llamar gravedad, si usted lo quiere poner. En vez de ponerle AC, le puede poner G.
Oh, ok.
Así es. This is a free gravitational force, acceleration, sorry. So another way of saying the gravity of the planet, if you want to say it in singularity terms. Another question? No hay problema, no hay preguntas. Okay, let's do it. Another problem. I'm going to move the camera a little bit to the right side.
Mister,
Ujú.
¿me puede dar un rato más para que copie?
Ah, bueno. Dele, dele. Como no me dicen nada, yo pensé que habían copiado. Dele. Ahí está. Bueno, mientras tanto ustedes están copiando, voy a copiar el ejercicio en el otro lado y me avisan cuando pueda mover ¿cómo se dice? La cámara. Ok. Meanwhile, the example number 2. The example number 2 says, two satellites are in circular orbits. Two satellites are in circular orbit. Two satellites are in circular orbit about Earth. About Earth. About around and about around. Ouch. Around Earth. Around Earth. Es que confundí yo la period. Satellite A, period. Satellite 8. Satellite 8. Satellite 8 is at an altitude of equal to the Earth radius. No es of, equal to Earth radius. To Earth radius. Comma. While satellite B, while satellite B satellite B is an altitude equal to and altitude equal to, to equal to twice the Earth radius. Twice Earth radius. Okay. The question is, what is the ratio? What is the ratio? What is the ratio of their periods of their periods TB over TA? TB over TA. Bueno, me avisan si puedo mover la cámara a la derecha, muchachos. ¿Puedo moverla? Ah, no, dice, mira, ¿eh? ¿Puedo o no la muevo? Sí la muevo. ¿Qué dicen?
Un poco,
Vamos a hacer, ya copiaron el 1, ¿no? ¿Ya copiaron el 1?
solo me falta la última parte.
Bueno, lo que pasa es que en esta aula tienen tirada, tienen colocada la cámara por un lado, por eso es. Ujú. Hoy sí, ¿lo muevo o no lo muevo?
Yo creo que sí, mister.
Vamos, hoy sí. Hasta le vamos a dar un pequeño zoom a lo más que podamos. Bueno, esto es lo más que puedo darles. All right, the problem says, two satellites are in circular orbit around Earth. Satellite 8 is an altitude equals to the Earth radius, whilst the satellite B is an altitude of equal to twice Earth radius. So the question is, what is the ratio of their periods? Okay, basically, before to solve this problem, we must establish what will be the value from the radius data. For example, the first altitude, altitude H, that's supposed to be equal the radius of the Earth, the altitude 8. Meanwhile, the altitude B, that's supposed to be equal to the double of the Earth radius. It's according what the problem says. All right. So if you really want to know what will be the radius of the satellite 8, remember the radius of the satellite 8, that's supposed to be equal the altitude 8 plus the radius of the Earth, right? And because the problem says, okay, the altitude 8 equals the radius Earth plus the radius Earth, the radius 8 will be twice the radius Earth. This is for one side. All right. How about with the radius B? In the radius B, remember that's supposed to be the altitude B plus the radius of the Earth. And because the problem says, okay, the altitude B is twice the radius Earth, twice radius Earth plus radius Earth, So the radius B, that will be 3 times the radius of Earth. We got the relationship between the radius. Now let's going to follow in what the equation says. We must looking for what will be the ratio between period B over period A. What is the formula for the period? Remember the period is 4 pi square radius B of the third power divided by G, mass of the planet. In this case, mass of the Earth, over. Same formula with the period 8. 4 times 5 square radius 8 Q power over G, mass of the Earth. What I have done in this case, okay, just to let you know, this is going to be period B over the period 8. The substitution of the same formula. Okay, what will be the interesting thing in this case? Well, because 5 pi squared is the same with this one, it can be canceled. GMA is the same GMA. So we can conclude the period B over the period 8, that will be equal to the division between radio B over radio 8, right? Just like this one. Radio B over radio 8. Because both are elevated to the third power, we can rewrite this expression. Yes or no? Because this one, this equal this one, we can cancel. GME is the same. So RBQ over RAQ, because both are elevated to the Q power, we can apply this law of exponents with fraction, and that will be elevated to the third power. So what will be the moment go through? Simple. TB over TA will be equal to, what is the value of radio B? 3 times radio the Earth over radio A, twice the radio Earth, elevated the third power. So radio Earth can be canceled. 3 times 3 times 3 will be 27. 27 over 8, right? For that reason, we can say the period time the planet B or the satellite B will be 27 8 times the period of time of the satellite 8. And if you want to divide 27 divided by 8, that will be 3.300 3.375 times the period 8. And this is going to be the solution set for this beautiful exam. Questions? Preguntas. Pues está todo claro, todo azul. Pueden preguntar con toda la confianza. Ajá.
Una pregunta. En el
Dígame.
ejercicio 1, en la
Ujú.
parte verde, ¿cómo podemos sacar el resultado en la calculadora?
Ahorita. ¿En qué parte? Ah, en la parte verde.
Sí.
Déjenme ver a ver si tengo en esta computadora, si tengo instalada la aplicación de la calculadora. Ay, no tengo instalada. A ver, permítame ver si puedo descargar la aplicación. Esto se llama simulador, calculadora Casio FX 82. A ver. Déjeme, permítame un segundito, a ver si puedo descargarlo ahorita. Ahorita. Solo deme un minutito. Siempre quiero... ¿Por qué no? Ah, de que qué bruto, hay que descargarlo de acá. Permítame, lo estaba cargando un poquito lento el internet, está. Ah, ok, excelente. Ok, vamos a ver. Permítame un segundito. Ahora share screen, calculadora. Ok, recuerden, pueden ver lo que es la calculadora, ¿no? Muchachos, ¿pueden ver la calculadora? ¿Sí o no? Hola, ¿la pueden ver? ¿Sí o no?
Sí, mister.
Bueno, muy bien. Recuerden que primero teníamos, hagamos esto. Primero coloca la fraccioncita. Pone paréntesis 6,600. Cierra al cuadrado. Abre paréntesis aquí. El otro es 6,67 por 10 menos 11. Cierre paréntesis. Abre paréntesis. 5,98 por 10, la 24. Ajá. Y abajo, como es un sobre, hacemos un doble paréntesis. Miren que abrimos dos veces. El de afuera es para protegerlo y adentro es para hacer el cálculo, que es 4, shift, este de aquí, cuadrado, cierro dos veces. Esta respuesta es antes de sacar la raíz cúbica. Por lo tanto, para sacar la raíz cúbica es muy sencillo. Le damos segunda función, shift. Tenemos esta funcióncita de aquí, raíz cúbica, y movemos teclita y le ponemos answer, ¿verdad? Y le damos igual. Y como puede ver usted, aquí me da el número 7,606,503. Pero si usted lo quiere poner en notación científica, shift mode, se va al número 7, que es scientific notation, y le colocamos 3. Y mire, ahí tiene el número que es 7,61 por 10 a la 6. ¿Entendió?
Sí, mister.
Dale pues. Bueno, entonces mis estimados aprendices, ya prácticamente solo quedan menos de 2 minutos. Lo vamos a dar hasta aquí. El día de mañana pues continuaríamos con otros ejercicios. No sé si les quedó claro entonces el ejercicio número 2, si hay alguna pregunta o está todo claro, todo azul. ¿No hay preguntas? ¿No hay preguntas?
No, mister.
Ah, bueno.
No, mister.
Bueno, mis estimados, si es así, Dios los bendiga, los guarde, los cuide. Los veo mañana a la misma hora por el mismo canal. Cuídense. Bye bye. So long. Take care of yourself.
Bye, mister.
Bye.